Hello students and viewers, I take this moment as the prestigious one to present this video session as a present to you all. This is K. Venkatesan from Department of Physics, Bharathidhasanar Matric Higher Secondary School, Arakkonam. Now I am going to introduce new topic 11th Standard Physics, second unit, Kinematics. The kinematics is nothing but it is a branch of mechanics, deals with the motion of an object without taking force into account. Okay, these are kinematics. See again, kinematics is the branch of mechanics which deals with the motion of an object without taking force into account. Okay, here the Greek word kainmano, see this is the Greek word. Which one is Greek word? Kainma. Here kainma is nothing but, see here, motion. This is called motion. Not only that, without taking force into account. This is a good, very, very important terms. This is the meaning of kinematics. The kinematics is nothing but it is a branch of mechanics. It deals with the motion of an object without taking force into account. Okay. The first one is the concept of rest and motion. First, what is meant by rest? Already we know the previous classes, rest is nothing but, see, let us consider an object. In this object does not change its position with respect to surrounding. This is the good definition for rest. Okay, see here, when a body does not change its position with respect to surrounding of the body is said to be rest. See the example for rest. See, tools lying on the floor, bench in the park. The next one is book on the table. This is a good example for rest. Okay, say what is meant by rest? Rest is nothing but, let us consider an object. In this object does not change its position with respect to surrounding. This is a good definition for rest. Okay, the next topic, motion. See here, motion is nothing but, let us consider an object. When a body changes its position, sir, how to represent the motion, sir? Let us consider one object. For example, car. In this car, changes this initial point, that one is final position. In this object, changes from initial position to final position with respect to surrounding. Surrounding is nothing but tree, house, here mountain, etc. Say this is a good example for motion. See, when a body changes its position with respect to surrounding, this is the definition for motion. Example, a car changes its position with respect to tree or mountain or anyone surrounding. Okay, see, the next one is types of motion. The first one is linear motion, circular motion, see, vibratory motion, rotational motion. There are 4 kinds of motion is here. The first one is linear motion. How to explain the linear motion? See, listen here, the linear motion is nothing but object moves in a straight track. Any one object moves in a straight track. So, good example for athletes running in a straight track. See, listen here, see, listen my dear students, when an athletes running on a straight track, this is a good example for linear motion. It covers only one direction. See here, x coordinates. It covers x coordinates. Already we know that basic concept. There are 3 coordinates is here, x coordinate, y coordinate, z coordinate. In these 3 coordinates we are calling Cartesian coordinates. In these Cartesian coordinates can be explained motion of an object. Okay, here only one direction only covers. So, for example, an athlete running on a straight track is a good example for linear motion. Is it clear? Okay, sir, define linear motion. The linear motion is nothing but when a body moves in a straight line. Okay, this is the definition for linear motion. The second one is circular motion. See the circular motion. Circular motion is defined as motion is described by an object traversing a circular path. In other words, they are calling, let us consider an object moves in a circular path. Okay, this is the definition for circular motion. The example for circular motion, the motion of a satellite around the earth. This is a good example. So, another one example, see the whirling motion of a stone attached to a string. For example, let us consider one stone and a string. Tie the stone, just you want to rotate, okay, or circulate. So that time it can be form of circular motion. Okay. The third one is rotational motion. The object moves in a rotational motion about an axis. This is called rotational motion. Okay, rotational motion is simple concept. See, listen here. Let us consider an object. For example, in our earth surface. Okay, in this earth surface, rotate about an axis or any one disc material, any one disc. Okay, in this disc, rotating about an axis. So this is called rotational motion. Okay, see, the spinning of earth about its own axis, the good example for rotational motion. Okay, the next one is vibratory motion. In other words, we are calling oscillatory motion. Vibratory motion is nothing but, let us consider an object. In this object moves in to and fro motion with its mean position. Okay, to and fro motion is nothing but up and down motion or left to right motion, anything. Okay, this kind of motion we are calling vibratory motion. The vibratory motion, in other words, we are calling, see, oscillatory motion. So this is a good example, oscillatory motion. See, movement of a swing. The next one is vibration of a string on a guitar. This is a good example for which one? Vibratory motion. In other words, we are calling oscillatory. The next heading, motion in one dimension. Motion in one dimension. See, listen here. A particle moves along a straight line. On one object moves along a straight line. This is called motion in one dimension. It covers only one direction. You know Cartesian coordinate system, no? 3 Cartesian coordinate system. S coordinate, Y coordinate, Z coordinate. Here, the motion in one dimension covers only one coordinate. For example, X coordinate or Y coordinate or Z coordinate. This is the motion in one dimension. See, definition for one dimension, a particle is moving along a straight line. In other words, we are calling one dimensional motion, in other words, we are calling rectilinear motion. Say, rectilinear motion. This is a good example. See, listen here. Motion of a train along the straight railway track. This is the first example. The next example, see here, an object falling freely under gravity to the earth. Okay, this is a good example for motion in one dimension. It covers only one direction. Okay, see, the next one is motion in two dimension. See, listen here, second topic, motion in two dimension. A particle moves along a curved surface or curved path, and also it covers two direction, or it covers two coordinates, x coordinate or y coordinate, x coordinate and y coordinate. Okay, it covers two direction. So this is the two-dimensional motion. If a particle moves along a curved path in a plane, then it is said to be two-dimensional motion. The good example for two-dimensional motion, coin, that means motion of a coin on a carom board. This is the first example. The next example, see next example, an insect traveling over the floor of a room. This is another one example. Okay, this is a two-dimensional motion. The two-dimensional motion cover two direction, two coordinates, x and y coordinates. Okay, yeah, there are 3 Cartesian coordinates. We know that in these Cartesian coordinates can be explained motion of an object. Okay, this is a two-dimensional motion. The next one is three-dimensional motion. A particle is moving in usual three-dimensional space as three-dimensional motion. It covers 3 coordinates. How many coordinates? It covers 3 coordinates, x coordinate, y coordinate, finally z coordinates. So it covers 3 coordinates. Okay, x, y, z. So example for 3-dimensional motion, a bird flying in the sky. It is a good example for 3-dimensional motion. 3-dimensional motion, a bird flying on the sky. The next one is random motion of a gas molecule. It is a good example for 3-dimensional motion. Okay, let us consider a container. In this container is consist of some of the molecules. In these molecules also, motion of the molecules or motion of the any gas particles moves in a 3-dimensional motion. 3-dimensional motion is nothing but it covers x, y, z coordinate. Okay, this is the good example for 3-dimensional motion. Good example, birds flying in the sky. Okay, the next one is elementary concept of vector algebra. Elementary concept of vector algebra. See, listen here. In our physics concept, some of the quantities possess magnitude as well as direction. Magnitude as well as direction. To explain the magnitude and direction and also understand the physical quantities, it is very important to know the properties of vector and scalar quantity. Vector and scalar quantity. First I am going to introduce vector quantity, scalar quantity. Define scalar quantity. The scalar quantity is nothing but any physical quantity possess magnitude, there is no direction. See here, any physical quantity, the physical quantity which are expressed in magnitude only or possess magnitude only, there is no direction. So this is the vector scalar quantity. The scalar quantity example, length, mass, time. See, this is the mass, this is the length, this one is time. This is a good example for scalar quantity. Say dear students, define scalar quantity. The scalar quantity is nothing but any physical quantity which can be expressed in magnitude only, there is no direction. There is no direction. This is a good example, length, mass, time. Okay. The next heading, vector quantity. Vector quantity is nothing but any physical quantity can be explained magnitude as well as direction. Magnitude as well as direction. So this is called vector quantity. The vector quantity example, displacement, velocity, acceleration, impulse, force, everything and all vector quantity. Okay. Say dear students, vector quantity define. The vector quantity is nothing but any physical quantity possesses magnitude as well as direction. Okay. This is the definition for vector quantity. See, listen. The next one is representation of vector. How to represent the vector quantity? See, listen here. See, this is the AB is nothing but AB vector. Here, how to represent the vector? This is a AB vector, no? How to represent? See, a vector quantity can be represented by an arrow head. This is the arrow and head. Okay, arrow head. So here, the next one is the length of an arrow. See, listen here. The length of an arrow. This is the length, no? In this length. The length of the arrow represent the magnitude of the physical quantity. Here, the arrow head, no? Arrow head. The arrow head represent the direction of any physical quantity. Okay. So, see, the length of an arrow represent the magnitude of the vector quantity. This is a magnitude. Sir, how to understand, sir? See, 4 centimeter. 4 centimeter one object moves in east direction. Okay, here 4 centimeters is nothing but this magnitude. East is nothing but direction. So it possesses magnitude as well as direction. Okay, see, the arrow head represents the direction of the vector quantity. This is a simple concept of representation of a vector quantity. Representation of a vector quantity. Dear students, I hope you all would have enjoyed this class, and I believe that it will satisfy your thirst of knowledge. Thank you.